Okay, let's dive right in. Today, we're shifting your entire mindset. We're moving away from just blindly memorizing math formulas, and instead, we're going to learn how to anticipate exactly what the examiner is looking for. Welcome to The Explainer. Look, today we are taking a chess grandmaster approach to your Cambridge mathematics exams. And what does a grandmaster actually do? They think 5 moves ahead. They don't just react to the board sitting in front of them, they anticipate their opponent's next mental move. In your case, the opponent is the exam paper, and the grandmaster you literally need to outthink is the Cambridge examiner. So let's set the stage with a real challenge. Imagine a real past paper question for syllabus codes 0580 and 0606. We typically see 2 types of students tackle this. Let's call them Alex and Sam. Now, Alex is a hard worker. Alex has memorized literally every single fact for these syllabus codes. But for permutations and combinations, Alex just dumps raw mathematics facts onto the page, completely ignoring the actual analysis. Then we have Sam. Sam definitely knows the math, but Sam rushes, entirely missing the specific command word requirements in a complex past paper question. By the end of this session, we're going to completely transform both of their approaches, and yours. Now, what's really fascinating about this is that it reveals the core truth straight from the source material. Top marks require so much more than just knowing your equations. When we look at Alex and Sam's answers, they're just riddled with red pen marks. Let's look at Alex first. Alex wrote down n factorial over n minus r factorial, which, yes, is technically correct for permutations, but they applied it to a combinations problem simply because they didn't analyze the context. Huge mistake. Then there's Sam. Sam actually got the right final number, but because Sam skipped 3 lines of working out, they lost all the method marks. A senior Cambridge examiner specifically notes that the leap from a solid B to an A star is all about multi-stage analysis. It's about showing the examiner your thought process step by step. You have to prove you aren't just guessing or relying on a lucky punch into a calculator. You literally have to lay out your reasoning like a logical roadmap. So we have to ask ourselves this absolutely crucial question to understand the gap between average answers and top-tier, flawless execution. Why is it that thousands of students sitting for the 0606 additional mathematics exam stumble right here? Well, the source material points out that students find this hard because they've been trained to chase the final answer. We all do it, but the Cambridge marking scheme is heavily weighted toward the journey, not just the destination. When you look at those red marks on Alex and Sam's papers, they didn't fail because they lacked intelligence. Not at all. They failed because they lacked a system. They didn't understand the specific assessment objectives that demand a structured breakdown of complex problems. Here is our roadmap for cracking the code on Cambridge Additional Mathematics today. We'll be hitting 1, the A-star difference, 2, core formulas, 3, the method mark strategy, 4, top 3 warnings, and finally, 5, deconstruct, solve, evaluate. Let's get right into it.
Section 1, the A-star difference, shifting your analytical approach.
This perfectly illustrates the academic benchmarks examiners are looking for. They prioritize deep, evidence-based reasoning over a really shallow understanding of a bunch of topics. Look at the left side, superficial breadth. This is our friend Alex, frantically writing down every formula they know, just hoping one of them sticks. Now look at the right, analytical depth. This is exactly where we want you to be. It's about structuring your reasoning so crystal clearly that the examiner literally has no choice but to award you full marks. To get that analytical depth, top students use a framework called PEAL, adapted for math. Point, evidence, explanation, link. You state your mathematical intent, extract your evidence from the data, explain via your step-by-step working, and link it back to the context. Before we continue and really break down how to apply this PEAL framework, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2, core permutations and combinations, the theoretical foundations. Okay, so if we want that analytical depth, we need to make sure our absolute foundations are rock solid. Moving on to the exact formulas you are required to use for expressions of n items taken r at a time. The syllabus demands absolute fluency here. First, permutations, denoted as p. These are arrangements where the order totally matters. The formula is n factorial divided by n minus r factorial. Think of a combination lock, which honestly should be called a permutation lock because the order of the numbers absolutely matters. If your code is 1, 2, 3, entering 3, 2, 1 is not going to open it. Then we have combinations, denoted as C. These are selections where order does not matter. The formula is n factorial divided by the product of n minus r factorial and r factorial. Think of choosing a committee of 3 students from a class of 20. It doesn't matter who is picked first, second, or third, it's the exact same group of people. Misapplying these two formulas is, for sure, the fastest way to lose points. The assessment objectives actually target these 3 distinct cognitive domains, meaning you have to prove you can do way more than just recite those formulas. Knowledge and understanding? Well, that's just remembering P and C. Application is simply plugging the right numbers into your calculator. But analysis? Oh, analysis is where the A-star lives. It's looking at a multi-part question that requires you to first use a combination to select a group, and then use a permutation to arrange them in a line, all while subtracting the scenarios where 2 specific people refuse to sit next to each other. That requires serious, deep, multi-stage analytical thought. Section 3. The Method Marks Strategy. Earning points for the process.
When you sit down in that exam hall, you aren't just solving a math problem. You are communicating a logical proof to an examiner. You must show your work clearly. Why? Because method marks are granted for systematically extracting data and applying logical steps. Imagine Sam rewriting their answer right now, transforming it from red marks to green check marks. Instead of jumping straight to answer equals 120, Sam starts by explicitly writing out the combination formula. Boom! That's a method mark. Then Sam substitutes the numbers into the formula explicitly. Boom! Another method mark. By showing the structured reasoning, Sam is banking points even if they accidentally press the wrong button on their calculator at the very end. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Which brings us to the number 3, specifically the top 3 mistakes identified directly in principal examiner reports. We've talked about the right way to do things, but to be a true grandmaster, you need to know exactly where everyone else is falling into traps. Section 4, Top 3 Examiner Warnings, Avoiding the Most Common Traps. Reviewing this table, you can see candidates consistently lose marks not because they don't know the math, but because they completely drop the ball on format, presentation, and context. Let's do a quick mental data scan challenge right now. Look at rank 3, answers not specific to context. Let's say the question asks for the number of ways to arrange cars in a car park. If your answer is a fraction or a decimal, you failed the context check. You obviously can't have 4.5 ways to arrange physical cars. Now imagine a student writes a messy paragraph saying, I used the permutation formula and got 50.4. Can you find the flaw? The sentence losing marks is the final answer itself. It lacks proper terminology, the presentation is super sloppy without showing the substituted values, and the context makes literally 0 physical sense. You must always review your final answer against the reality of the question asked. To avoid these silly mistakes, the source material highly recommends utilizing a visual story method to help lock these rules into your brain. When you are speed writing a perfect PEL structured justification for a problem, picture a combination as a giant mixing bowl. You throw all the ingredients in and the order doesn't matter, it's just a selection of items mixing together. But picture a permutation as a strict, ordered podium at the Olympics. Gold, silver, bronze. The order absolutely matters there. Linking these visual stories to the formulas prevents you from triggering examiner warning number 1, forgetting the proper format, and applying the totally wrong concept. Guys, this is a massive red flag from the examiners. You must strictly define your terms and use clear conventions and headings to prove your understanding. If a question asks for a comparative analysis of 2 different probability scenarios utilizing permutations, you need to use comparative connectives, words like whereas, in contrast to, or similarly. Top-scoring candidates demonstrate true evaluative thinking by laying out their terminology right from the start. Never let the examiner guess what N or R represents in your specific working. State it clearly. Let N equal 10 representing the total number of books and R equal 4 representing the books selected. That level of clarity is the exact hallmark of an A-star student. Section 5. Deconstruct, solve, evaluate. The ultimate exam framework. This 3-step framework right here is your ultimate cheat code for tackling complex data interpretation skills. It's built on 3 rules that guarantee top marks. Rule 1 is command word decoding, which fits perfectly into step 1, deconstruct. You highlight the command word and extract every single piece of numerical data given. Rule 2 is peel framework application, which is step 2, solve. You break it down into logical steps, explicitly showing your formula, substituting the values, and showing those intermediary mathematical steps. Finally, Rule 3 is the time management matrix, which pairs perfectly with Step 3, evaluate. You shouldn't spend 10 minutes evaluating a tiny 2-mark question. Look at the marks allocated. Use your remaining time to check if your final arrangement number makes logical sense. If you were calculating the number of ways 5 people can sit in a row and you get an answer of 2 million, your evaluation step should trigger a massive alarm in your head that something went mathematically wrong.
This timeline shows the exact progression of a flawless, top-scoring examination answer. It moves logically from start to finish. You begin with step 1 by defining your terms. Then you move to step 2, selecting the correct analytical framework, deciding if this is a mixing bowl combination or an Olympic podium permutation. In step 3, you execute clear notation by laying out the math methodically. Finally, in step 4, you justify your recommendations by checking it against the context. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here. So think about that final question as you practice your past paper questions this week. Are you just trying to memorize, or are you mastering the playbook? Focus on the process, not just the final number. To be the grandmaster, you can't just memorize the moves. You have to understand the entire strategy behind the board. You now have the examiner's playbook. You understand the difference between superficial breadth and analytical depth. You know how to deconstruct, solve, and evaluate. The next time you sit down with a 0606 additional mathematics paper, I want you to visualize your logical steps, secure every single method mark, and approach each question with absolute confidence. Keep practicing those multi-stage questions, trust the process, and we will see you in the next explainer.